This video is meant for Mrs. Rose's AB Calculus class, and it is on curve sketching. Okay, so one of the things we want to be able to do is analyze a graph or analyze a curve and then be able to sketch an original, especially if you're given a derivative curve. So one of the worksheets that you got in class or are going to get in class is this graph of g prime of x. And we want to be able to answer questions like, where does g have a relative minimum and a relative maximum? Where is g concave down? Where is g concave up? And then ultimately, at the end of that, we want to be able to sketch what a graph of g might look like given the information we can get from the graph of the derivative. So, like what we've been working on with critical values and intervals of increasing and decreasing and intervals of concave up and concave down, we want to look at where g prime of x is equal to 0 or undefined, and that's going to be our critical values. That's happening at -2, 0, 2, and 4. And we also want to look at where g double prime is 0 or undefined. And those x values are at -1, at 1, and at 3. So when we go to analyze this curve, we want to set up intervals that go over the entire domain and are broken up at every critical value and every point of inflection where g prime of x is 0 or undefined, or where g double prime of x is 0 or undefined. And we're going to look at what is the sign of f prime of x and what is the sign of f double prime of x. Now when we're looking for the sign of f prime of x, we're looking at, oh, this is the graph of g prime of x. So when we're looking at g prime of x, we want to figure out where g prime is positive and negative. So because this is the graph of g prime of x is negative here, positive, positive, negative, negative, positive, positive. So everywhere it's below the x-axis, we write a minus sign, and everywhere that it's above the x-axis, we write a plus sign. Now we want to look at g double prime of x. Now g double prime of x is a little bit different because it's the slope of g prime, and we're given a graph of g prime. So g double prime is really the slope of this graph because g double prime is the slope of g prime. So this is a positive slope all the way to -1. So it's positive on the first interval, positive on the second interval. From -1 to 0, the slope is negative, and it stays negative until you get to 1. From 1 to 2 and from 2 to 3, that slope is positive, and from 3 to 4, that slope is negative. So now we can make conclusion statements about where the g graph has a relative minimum and a relative maximum. We know that g has a relative minimum everywhere that the graph changes from a negative g prime to a positive g prime at -2 and +2. And we write our answer like this. G has a relative maximum everywhere that the g prime changes from positive to negative. That only happens at x equals 0. And we write our answer out like this. G has a relative max at x equals 0 because G prime of x changes from positive to negative. G prime. Alright, and then concave up, concave down, we're looking at the second derivative. So anywhere that the second derivative is positive, then we're talking about where g of x is concave up, and anywhere that g double prime is negative, our function is concave down. So we write our answer like this. G of x is concave up on -1 to 1 and 3 to 4 because g prime of x is decreasing, and g of x is concave up on -3 to -1 and 1 to 3 because g prime of x is increasing. Okay, then what we can do is, based on the information we got from our g prime of x graph and these 2 points, we can sketch a graph for g of x. So the first thing we're going to need to do is get basic curve shapes. When the function has negative slope, or it's decreasing and it's concave up, it's going to look like this. When it's increasing and concave up, it looks like that. Increasing concave down, decreasing concave down, decreasing concave up, increasing concave up, and increasing concave down. Once you have your basic curve shapes and you've plotted the 2 points that the problem gave us, the -3, 3 and the 4, 6, then we just need to have this basic curve shape on each interval. So from -3 to -2, I'm going to draw this curve shape, and then from -2 to 1, I'm going to draw that shape, and then here, and then here, here. Oops, I didn't want to do that part. Up. And the last one looks like that. The y values do not matter because the graph, the information given to us, did not include anything about the y values except for at this point and this point. So your y values could be anything you want as long as the basic curve shape is there, like you got from your sine graph. That's all there is to curve sketching. Good luck on your homework, and if you have any questions, please see me during class or during CAV morning.